Okay, Math 9s, welcome back. In this section, this video that I've dubbed 1.2 and a half, because it doesn't correspond to any chapter in your textbook, but I think it's important just to understand the difference between area and surface area. Understand the difference between area and surface area is going to be one of our focuses. And then what we'll do with this is to show up to class, and we'll measure and calculate area and surface area of objects in class. Okay, so first of all, just a quick understanding that area is talking about two-dimensional objects. Surface area is for three-dimensional objects. Two-dimensional objects are objects that you can put on a desk, like rectangle, triangle, and a circle. And I mention these three because they are going to be useful in calculating surface areas. With a rectangle, if you have length and width, your area is just length times width. If you have a triangle, your area is base times height divided by 2, or base times height over 2. And with a circle, if you're given the radius of a circle, your area is pi r squared. Okay, pi is a number that is irrational. You've heard of this before. Pi is a ratio between the circumference and the diameter of a circle. We'll talk more about that in class. It's an irrational number that is 3.14 and with an infinite number of digits. It's also a button on your calculator, so whenever we're using pi, we'll use the shortcut of and the exact number of pi on your calculator instead of 3.14 to get an exact number. Okay. 3D, three-dimensional objects are objects that you can hold in your hand and they come off the desk, I guess is how you explain it. So there are a bunch of three-dimensional objects further down here on the page. I've listed or shown a few that we don't specifically cover in Math 9. These are objects that you'll see in grade 10. The objects that we see in Math 9 are rectangular prisms. Here it's listed as a rectangular solid, but rectangular prisms, triangular prism, triangular prism, and then cylinders. Okay, so prisms. I'm going to scroll back up here and just give a definition. Hey, what's a prism? A prism is a three-dimensional object that has the same cross-section throughout. So I'm going to scroll back down here. So a way to think about that is just karate chopping this, let's say triangular prism, like just karate chopping it, cutting it there with the karate chop. This is not very artistically sound, but karate chopping it and realizing that, hey, if you karate chop that, the cross-sectional area is going to be the exact same as one of the ends of the objects. Okay, so same thing with with a rectangular prism. If we karate chopped it, it would have that same area of one of your ends. Same with the cylinder. If you karate chop this thing, then the cross-sectional area would be a circle for a cylinder. Okay, so when we talk about the area of three-dimensional shapes, we talk about it in terms of surface area, and the surface area of a three-dimensional object. Something to keep in mind that this is the sum of the areas of all of the faces. Sum of the areas of all of the faces. Okay, so well, what's a face? Well, the sum of the areas of all the faces. So a rectangular prism, this is an object that has 6 faces. So it's got a left and right, it's got a top and bottom, and it's got a front and back. Okay, triangular prism, if we're looking at how many faces this object has, how many do you think? How many faces does this thing have? Okay, so I'm just going to give this to you as, hey, there are 5. There are 5 faces. 2 of them are triangles, or the ends, and there are 3 rectangles. Okay, so the surface area of a triangular prism is just 5 areas all added up. Okay, when you're dealing with a cylinder, I'm circling this because this shape here is just what's called the net of a cylinder. So it's a cylinder that's unwrapped. So with the net of a cylinder, we can see, hey, it's just 2 circles. It's just 2 circles and a rectangle. So the formula that we are going to be using for the surface area of a cylinder is 2 pi r squared. I'm only going to write this one down because the other ones are rectangles and triangles just all added up. And this one's a little bit special. Surface area of a cylinder, this is just 2 circles. This is just 2 circles. And this one here, that's just a rectangle. That's just the sides. Okay, where 2 pi r is the circumference, or the distance around. Let's see if I can fit these both on the same page. So it's the distance around the circle, which corresponds to one of the dimensions on the rectangle, and the other dimension is the height, and that will give you the area of that rectangle. Okay, so just a reminder that these formula are all on your formula sheet. You have the area and surface area formula for different objects of squares, rectangles, triangle, circle, and then there's your cylinder formula that we just wrote on the front page. Okay, and if you go to the back side of this formula sheet, so sorry, let me back up. This formula sheet on the front side, this is one that you will get. This will be provided to you on quizzes, tests. You won't have to memorize those formulas, although it's kind of nice to do so. On the back side, I've taken an excerpt from the Math 10 data pages from the provincial exam. Note, you're not going to be given this for grade 9, but this is a nice sheet that shows us both the surface area and volume. Volume is not covered in your textbook, but we'll talk about that. Volume is how much space an object takes up. And then for a cylinder, for the surface area of some different 3D shapes, you have cylinder there. You see that these 3 shapes, sphere, cone, and a pyramid, these are all shapes that you'll cover in grade 10. Okay, so the formulas are there, surface area and volume. Once you get rolling with this, it's really a plug and chug. You have to figure out what numbers you have, and then you're going to plug numbers into formula and chug out an answer. Okay, and then you have your rectangular prism, and then your general right prism, which is largely what we're dealing with in grade 9. We're looking at the surface area, and there we see, hey, that's just going to be the sum of the areas of all of the faces, which we talked about on the other sheet. Okay, so we can keep that in mind. Okay, so we'll flip back over here, and just to wrap this up, our big idea here is to just understand the difference between area and surface area. The difference between area and surface area. Okay, so when we come to class, our assignment is going to be an in-class assignment where we're finding the area of 2D shapes, 2-dimensional shapes, and we'll find the surface area of 3-dimensional shapes. So this will be an in-class assignment. Okay, so hope that gets us rolling with area and surface area. Thanks for watching, and we'll see you soon.